Hi guys, welcome to a new TheLab tutorial from Produce with X School. Today I'd like to create something really simple. We have V-Ray for Houdini. It is out since a little bit of time. V-Ray is a really powerful rendering engine for many software. It is available for 3ds Max, Maya, Katana, and many other platforms. So now it is time to have it inside Houdini. So we have more option. We have Mantra, we have Arnold, we have Redshift, we have Renderman, and now we have also V-Ray. So today is just an introduction. So we're going to prepare a really simple fluid animation, and then we go to play a little bit with some feature in V-Ray to see how we can render a scene like this one. So we see some shader, we see some properties from V-Ray and stuff like that. So that's what we are trying to achieve. Obviously the simulation is really rough, we have some instability, it needs a little bit more love to be perfect, but it is nice to play with something like that to see how V-Ray can work and play inside Houdini. So that's the basic scene we have. You see we have an animated mesh that is an emitter. We have a little table. It's really simple. It's created, you see, with some primitives, and each primitive is then merged inside the merge node. Then we have just an assign color node. Let's see the parameter with P. And then we have a UV project node to have some basic UV inside this model. Over the table we have something more. We have the statue. The statue is coming from a free model over the web, and you see it's something I converted using 3ds Max. So the model is really huge because there is a problem with the scaling between 3ds Max and Houdini when you go to convert in Alembic file format. Then I'm using a convert to poly node just to be sure that everything is converted in the right way. Then I have a node to fix the scale. You see, I try to find, usually it's 100%, 100 times bigger, so I'd like to have a nicer scaling, so that's why I set the uniform scale to 0.005. And then I change it with a transform node, the position, to have it over the table. Then we have a simple mesh that is going to act as a meter, so you see that is animated. We have some rotation and some transform node. Also this one is really simple. We have a really big tube. You can see how much it's big. It's just a basic. Then I created a group to remove some face. Then I used the blast node to remove this face. Then I used a poly extrude to have a 3D version of this model. Then I selected some, I used the group to make a selection, but you know you can do also another way. And then I used the sub-transform to make a different shape. Then we have a subdivide to have a smoother version of this mesh. Then I fixed the position and the scale of this model, so we have it there. Then I use a node color just to have a color to see better the stuff inside the viewport. And then we have a transform node with animation, so you see there that we have an animation over the translation and something around the rotation over one axis too. So that's what we have. Really simple. We are going to use this one as a meter, and we try to create a viscosity to create some kind of fluid that can be similar to a chocolate. So our main purpose is not the simulation, so we go really fast to create the simulation, and in this case we go to use the shelves because it's really simple, so we can go with something really basic. Okay, so we can go inside the particle fluids. We can use the emit particle fluid button, so we press this one. It is asking if we have a fluid object, but we have nothing because we are starting from zero, so we can just press enter. And you see that we have the creation of all stuff we need for the fluid simulation. We are working with not with water, so the particle fluid interior is not needed. We can set to off, or if you like, you can directly remove it. We have the particle fluid for the mesh, and we have the dot for the simulation. So it's everything really basic. Let's go to select here. Let's create a panel, and we can call it chocolate sim. Then press the C button, and we go to have a different color to have some coloring there inside the network to have some nicer look. Okay, we have to play with many stuff. If we go there inside the emitter, you see that something is changed. We have the create surface, and this one is useful to create the emitter. So let's select this one. We see nothing because we have to play a little bit with more stuff. First of all, let's go in the DOP and press L, so the layout is done. And you see that the area for the simulation is really big because we are talking about 50 meters. We can change it manually. So you see, for example, there we can go inside volume motion. We can say 2 meters, 2 meters, and 2 meters, and you see that the area is changing. Or we can use the handle and manipulate everything by hand. So we can scale it to have a really little area. We don't need so much space there because the simulation is related just to a little area, so it is something we can do in this way. By the way, if you like to have a more precise, we can be more precise. It's something I prepared before to be sure that everything is done in the right way. So let's say 25 centimeters over the y-axis and 36 centimeters over the z-axis, and the center is to 0.14, 0.14, and minus 0.01. Okay, so now we are sure that we are picking the entire area for the simulation. Okay, we can go there for the particle simulation. Actually, you see that in the particle fluid we have the particle separation in this is set to 10 centimeters, so it's really big. Let's go really low, so let's say maybe half centimeter. You see that we are starting to see the volume about the emitter, so we can go back there. And if we like, we can play with the scaling and the various activity there for the shape, because you see it's not so precise, and I like to have a better shape. So actually the voxel size, that is the resolution of the volume there, is linked to the particle separation. By the way, I'm not sure if I'm going to have a really low particle separation or not, so we go to unlink this value, this parameter, so we can manipulate it manually. So right mouse button there and delete channel, and now we can write our value. So let's say 0.015. So you see it's really precise. If we like to have it with a lower shell thickness, we can go lower. Let's say maybe also there 15. So you see that it's really precise. And then we can move forward with our other value without problem. Something I like to do is to add a point velocity to control the random velocity for the emission. By the way, let's see what happens if we go to play. You see that the particles are falling away, we have no collision, and we have nothing at the moment. So let's go into DOP, and here let's say that maybe we have an higher resolution, 2 centimeters. It's a little bit better, and I like, you see we have just the particles falling down. I like to add a little random speed, so we go for a point velocity, okay, and add this one. Let's say random curly velocity. So we go essentially to have the basic value set to value, because the speed will be set by the car noise, and then we have just to add the add car noise. You see that we have a variation at the first frame. So if we go, you see that there is something random, but the scale is really big. So the first thing we have to change is the wheel size. Let's go to 5 centimeters. Let's get to play. You see that we have a really big randomic movement. It's really too much, and that's about the scale. The scale is really high. Let's say that it is maybe 10 times lower, so 0.1. So we should have just a little bit of random movement. Okay, so it's just a little bit noisy. Okay, perfect. We have to define the collision. Actually, we have no collision with meshes, so we can say that the table, you can do it for each one. So you can see that this one is a static mesh. We don't need collision with the other piece, but we can have collision with everything. The statue is a static mesh, and now it should work. If we go there, L button, you see that everything is done. If we go to simulate, you see that we have collision with the meshes. Just to be sure, because the scaling is really low, I like to double check the shaping for the collision. So if we go there and we say collision, we can show the collision guide. It is a flat object, so it should be good, but just to be sure, we go to a lower division size. In this way we have a more precise mesh, and then we can remove it, this one, because it can slow down the simulation, because it's created for each frame. And then the Buddha is the same. It's not so precise, so we can go lower and lower. Let's say 1. So you see it's more precise. Okay, nice. We have for sure a nice collision. It is not so complex to do the simulation. And let's see what happened. Okay, you see collision, actually it's behaving like water, but something else I like to change is the solver, because actually it's using, you see in the volume motion, it's using the splashy kernel, and this one it's working about over the velocity transfer, but this one is better for bigger splashy simulation. We have nothing that is related to something like that, so we can go to use the Swirly kernel in this one. It's maybe we can see something so complex, but it is the best way to use this one, because we don't need to play with splashes and stuff like that. Okay, so whatever else, we can work on the simulation value. I mean, we have nothing to do so complex for this one. We have more to play with with rendering. So let's see if we like to change something inside physical properties. We have to work with viscosity. To have the viscosity, we have to say to the solver to create the viscosity. And you see that we have it there. Viscosity is set to off. Let's say enable viscosity. In this way, it is going to create the viscosity information, and then we'll go to play a little bit with our surface tension too. By the way, now we have the viscosity, so we can say to this fluid that is viscous. So viscosity, let's try a really high value, and let's see what happens. We get to simulate. You see that it's behaving in a really different way. Obviously, this viscosity is really high. It is more like a cream or a really dense fluid. So I like to have something that is less viscous and more liquids. So to do something like that, but it is really nice because it can be useful to create something for a commercial, for example. Let's mention something like an ice cream or something like that. So let's go back. We need essentially to say that we like to have a lower viscosity. So I think that the lower value has 5 can works. So it will be not like water, but you see that we have a little bit of viscosity, viscous liquids. Okay, it is playing in a really nice way. Okay, whatever else, I like to have a little bit of friction over the surface. So let's go for just a little bit. 1. So the particles will have a little bit of friction over the surface, so it will slow down when they are colliding over the surface. And you know, it's not so complex to create something like that, because we have nothing to do with complex value and stuff like that. Maybe we can just play with a surface tension. This one is able to create tension over fluids. It will be really nice to create some strange and complex simulation. In this case, you see that about our scaling, the value that is used by default, 10, is really high. So we have to lower this one. Let's try something like 2. You see that it's we have a tension, so it is behaving in a really more different way. At this scale, it means that it is too high for the kind of effects I like to simulate. So we have to go lower. Let's say maybe 0.5. So it's really low. It's just to add a little bit of tension you see over the fluid. And the shaping is better than before, because you see there is tension, so we have this kind of scaling, and then it is behaving like a viscous fluid. Okay, so stop. If we go inside the particle fluid and we go in the surface preview, and we ask to see just the particles. Obviously we see this kind of particles, but we can see the fluid. This is really fast because it's the preview version, so you see that it's behaving in the right way. Okay, so I like to finalize this simulation, and to do something like that we have essentially to move down with scaling there, the particle separation, and I think that we can go, for example, for 0.01, so it will be really high detailed. We can maybe go a little bit lower with the surface tension, still a little bit lower, to something like 0.03. And if you like, you can use a little bit more sub-steps to have a more precise simulation. But you know, I have to do fast preview, so maybe we can stay with this value, the default value. Let's go to have some simulated frames. Then we are going to cache everything, so don't worry about it. You see that simulation time is fast enough. Okay, perfect. So Control S, and then in the particle fluid we can go to compress everything. We can cache, and let's say that we go to cache just maybe 50 frames to play with the lighting. So inside the compressor there we say right mouse button, delete channel, let's use 50 frame, save to disk, and it's going to save the cache. You see, it's really fast. So cache is done. We can say load from disk. So you see that's the mesh we just saved. Okay, we have to play with a mesh to have a nicer look. So let's say to see this one, that is the final measure. You see it's slower than the other, but it is better because we can see essentially the right final mesh. We have different things that can be changed, and we can play with. So we can scale down a little bit of voxel scale. Let's go to 0.5. So we have a little bit higher resolution mesh with more precise mesh around. If you like to have more polygons, and you can use the adaptivity. So you see that if we go, for example, at 0.015, we can have a denser polygons. If we go high, we'll have less polygons. Okay, you can find the best compromise as you prefer. We can go with this value, and let's go to the filtering. The filtering can give us the possibility to filter a little bit the mesh, because you see that we have some dots around, we have some some droplets, and it is not so smooth, so we can do something. Let's add the smooth filtering. This kind of smooth, the mean cubital flow, is really nice, but it needs more sampling. So let's go higher, for example 25. Okay, you see that we are going to have a smoother result. Let's go to double, 50. Okay, it is smoother. We are maybe losing a little bit the quality because it is really smoother than before. If we like, we can have another smooth over it. Let's use this one. Okay, you see that we are eroding the fluid. If you like, you can have a little bit of delay and erosion, and in this way you are going to have a more precise mesh. We can have less thickness. You have just to find the good compromise between, but it's slower to be simulated, so I prefer to be really fast. And we can go to export this one. We go to export, in this case, just 50 frames. So right mouse button there, delete channel. Let's go until the 50, and then we say save to disk. So meshing is done. Let's say load from disk, and we can say this one. Okay. So you see everything is done. It's not bad. I like to use a different node to play with a mesh. So we can copy this one, and then let's create a geometry, and let's say chocolate loader, and inside we go to this one, load fluid. Sorry, obviously it's using the naming, sorry. I was not taking care about it. So just to be sure that we have a really nice looking mesh, I go to add a subdivide node. Okay, you see that we have more polygons, and then this one is not visible. And this one can stay there. Let's say maybe that the color is different, just to know that this one is the one we need to use. Control S. So we can play with it. So let's say, for example, that we like to have a camera from there, new camera. So that's our point of view. Maybe we can move it there. Let's lock so we can manipulate this camera as we prefer. Okay, the camera is ready, and we have the possibility to add properties to the camera from V-Ray. You see that we have a shelf from V-Ray. If you have not this shelf after the installation, you have just to play with a plus button, and then you have the V-Ray, or you can find it there, V-Ray. So let's go in V-Ray. If you like to have the V-Ray property for the camera, you see that there you have, for example, the camera properties, press, and then the camera has the sampling and has the V-Ray stuff, so you can play with it. It is essentially the standard camera as before, but we have more properties coming from V-Ray. Let's start playing with the lighting and the rendering. So let's go in the output, and we go to tab, and let's create an IPR, and let's go to create a V-Ray renderer to have all the information we need. So this one is the one with all the parameters, and this one is the connection to the IPR. It means that if we go there in the render view, let's say to use the cam, and let's say to use the IPR, if we say render, it is opening, you see the viewport there. There is something I done previously, so give me 2 seconds to fix it. Okay, that's the render. Now it's fixed, so we can interact with this one. So we can manipulate everything. We can rotate the view. We can do everything else. So we see we have complete access. You see to how it is looking. So we have to start playing with the lighting. So let's go to create a light. We need to create V-Ray lights. So if you go there, we have the lights, and we go for a dome light. The dome light essentially is the similar to the environment light in Houdini. You see it's really fast. We have to play just with there we have the possibility to rotate, and there we have all the information about the lighting. For example, enable, if you like to enable this one or inside the viewport. And we say that it is a dome spherical because it is a spherical dome. If you like, you have this really nice feature, is the adaptive dome. It is really fast when you are inside some environment, so like an interior. So if you like, this one can be really useful to have a really fast illumination. You don't need anymore the necessity to speed up with the portals, so it's really a beautiful feature. I'm going to use a texture, so I'm going to use a texture I prepared with Tervigen, so it's a really simple map. Let's go for this one. Okay, now it is using the map we just created. You see that we have it inside the viewport. It's visible, so that's how it works. And I like to have more lighting, so let's say 2.5 to have more light inside. And then we have the subdivision to remove the green. We have just 8. Let's go higher. 256 is the minimum amount, and in a future tutorial we'll talk about how to play with the sampling with V-Ray. So for the moment we go to have something simple, just some basic value I'm giving to you to reach a nice quality. Actually we are playing with a progressive renderer, so you see it's really fast, and you have also some information that are inside the V-Ray console. So the light is done, the camera is done, we need to start playing with the material. So let's go in the material, and we can start playing with, for example, with the statue. Let's go to create a V-Ray. We have V-Ray material there. We have a lot of knots. Let's go for the material, and for example, let's go with an alt surface. It's the standard we have also, for example, in Arnold. And let's say this one is plastic. We can use the drag and drop to put this shader over the statue, and we get to play with just some value and some parameters, so something really simple. Let's say that we go for 1 for red, 0, 5 and 0, so it is something like a yellow color. And I like to simulate some kind of plastic, so let's go to have a higher sampling for the reflection, because it's possible that we go to have a nice reflection. So first of all, we have the reflectivity here, we have the IRR there. Let's say, for example, a really high. If you set 4, you see that we have a reflection. We have roughness, so we have a glossy reflection. Let's say that it's lower, so just a little bit. And if you like to have an higher sampling for the glossy reflection, you have to play with this one. Let's go for a 64 actually. If you like to see just an area, you can press this one, and you will see that now the rendering will be done just in this area. Other things that are really nice there, we have many features in the frame buffer. Here we can see the channel, you see, so just RGB, we have the alpha, we have the possibility to see the various render elements there, so I mean the passes and other things that can be useful there. Actually, you can save the image, you can stop, you can restart with a progressive here, and then we have many features. For example, this one is the history, so we can set to on, and then it will start to save the image when we render something. So we have just to say to prepare everything. We have the compare between renderings, so we have the possibility to control other tools, like there you see we have the possibility to control the exposure over the image. We have many possibility, and we can do whatever we like. So you can just close this one, and you see that we go to change the temperature. We have a color control over the hue and saturation. So it's really powerful and really fast. So we can do many things and many adjustments. Okay, so we'll work on something like that in a coming tutorial. So for the moment, it was just to let you know that it is really more complex. You see that there you have the LAT, you have the OSHO, you have a lot of things. So let's remove this one, let's remove also the other, and let's stay with the default value. Then I like to add the scattering. So in this shader, it's really simple. We have the mix. First of all, let's go back to have less reflection. So let's say that the strength is 0.65, so it's less reflective. And let's say that the IRR is 1.6, so not so much high. Let's go to have the scattering, and to have the scattering we have to decide how much is the mixing of the scattering. Let's say 1. So you see it's working now with the scattering. The scattering needs to be tweaked, and we have 3 layers as a skin shader. Let's say that we have 0 for the second layer and 0 for the third layer. So we play just with 1 layer, and the radius actually is 1.5 meters, so it's really out of scale. Let's say, for example, 5 centimeters. You see that it's starting to play in a nicer way. And let's go for some kind of yellow color. So something like that. Okay, um, it is nice, but maybe the scattering is too much. So what we have to change is the radius. So let's go to 1 centimeters. So we have just a little bit of scattering, and it will be more similar to a plastic shader. That's done. I don't want to do so much complex things. Just to be sure that we have less grain, let's use an high value for the scattering. We go for 128, but again, we are not taking care about the grain, playing with all the render passes, so we have to talk about the sampling in a coming tutorial. Let's play with a chocolate. So we need a shader for this one too, and the chocolate we can use the VRDF shader from V-Ray. We have another kind of shader. Sorry, we can move this one. So V-Ray material. Okay, and you see that we have the two different material. We have the some possibility to create also complex material if we need, for example, displacement or stuff like that. By the way, let's go with something simple. So we go with a standard V-Ray material. So V-Ray material, and let's say this one is the chocolate. We go to assign the material. So let's go to make a few change to have something better. We have to change the color, so we go to something like a brown color, but I have the value I found, so 0.062 and 0.0023 and 0.002. So I just wrote a 0, that is too much. Okay, now it is brown. We have no roughness, we have nothing that needs to be changed there. I like to have reflectivity. Actually, we have no reflectivity. Reflectivity can be controlled by the color value. So you see that, for example, if we go to white, we have reflection. So this is the value of the reflectivity. We go for something lower, maybe something like that. So a little bit of reflection, but nothing so special. Here we have the glossiness. The glossiness, the possibility to control the blurry over the reflection. So we are controlling the glossiness of the roughness. You know, we have the glossiness value, so it's the contrary about the roughness. So if we like to have a little bit of blurry reflection, we have to use a lower value. If we go really low, you see that it's losing completely the quality, and it depends on how you like to create this chocolate. By the way, I like to have some nice reflectivity, so we can go with 0.9, and then we get to have a little bit more subdivision. Nothing so high because the glossiness is not so high. Actually, it's going to use the IRR from the refraction, so you see that it's set to 1.6. If you like to play with it, you can unlock and you have the value there. So obviously if you go really high, you have something more like a metal. Okay, we can go back to 1.6, it's not a problem. So other things, we can have this material really simple, so just some reflection and that's all. A bigger area, I like to work on the wood material, so we can start playing with some texture. So let's go to create again a VRDF material. So we say V-Ray material, V-Ray material. Let's call it wood, and we can assign to the plane. For this one, I like to use some texture to control the diffusion. So let's go for V-Ray, and we have the texture file, image file. And let's see, this is the good diffuse. Okay, connect the color to the diffuse channel. We have to decide which is the bitmap. We have many parameters there. By the way, today we go just to use the file. So we choose this one, and I have this one in the downloaded folder. So downloads, and it's a good material. The texture comes from texture.com. It's the 1 key resolution, so it's the free one. And you see that there, for example, you have the color space, so you can see if it's a linear image or it is an RGB. And then you have many things there. For example, you have some color tweaks, you have alpha tweaks, you have the placement, you have the UV noise. By the way, the UV are controlled from the projector we used before, so we don't need anything to play with. Then I like to control also the reflection over this material. So let's go in the reflection. Actually, we have no reflectivity. We say to have the reflectivity set to white, and you see that everything is reflective. If we like to play a little bit with, for example, the glossiness, we can do with a value. So you see we can lose the precise reflection, but I like to use the texture. I don't have the glossy reflection for this material, but we can create it using a color correction node from V-Ray. So V-Ray, color correction. Okay, so we say to connect the color from the diffuse, and then we use the color output from there to control the reflection glossiness. Okay, how it works? Actually, we can, for example, play with the brightness. So if we go to have brighter color, you see that we are going again near the white, and this way we have obviously more precise reflection. If we go lower, obviously we have more glossy. We have the possibility to control the contrast. So we have some area where we have less glossy and area where we have more glossy. So it depends on the stuff you like to simulate. We can play a little bit with this value to find the best compromise. So I like to have a little bit of glossiness, but I like to have also a little bit of nice reflection. So in this way it seems working in a really nice way. Okay, it's a simple material. Actually, we have no bump, we have no control over the reflection, we have nothing. But it was just to introduce you to the use of material. You can do the same, for example, using a color corrector to control the reflection. What I mean, let's disconnect this one. If we go to copy this color correction there, we can go to control the reflection. So you see that we have the reflectivity. Let's say that this one, the bright is 1, maybe is 2, so it's really bright, but we can decide maybe we have to go back to 1, and let's say the saturation, so we have less color, and we can have, you see, some differences using the contrast. So we have some area where we have more reflection and some area where we have less reflection. That's depend on the look you like to create. Let's connect again the glossiness. So that's another solution. What I like to have is to have the displacement there, to have some details. You can use the bump, but we can use something nicer using the displacement. So if we like to play with the displacement, we have to use the object properties. So let's go in the material. Let's go in the object. Save. If you have no object properties, You see that there I have it. You have just to select the object and then you have to press the object properties that will goes to add this tab. In this tab we have the displacement. So there is the possibility to add the displacement using a texture. So let's say that the table has obviously the render displacement, and we get to use the same texture we had before. So we get to select the one we used for the diffuse. We are not taking care about the black and white, so it's really simple, don't worry about it. The default value for the amount is 1, so remember that it will be really high. So you see nothing because we are inside the mesh. If we start to go lower, you will see that the mesh is generated, but obviously it is really, really high. Here we have the possibility to say to pre-tessellate the mesh or do the mesh in the on-the-fly type. By the way, we can stay with this one. It is the possibility there to have the standard displacement, a 2D displacement. We'll see soon how it works, and then we have the vector based. So let's stay with the default. We have here the possibility to shift the mesh. So if we go to mid shift, you see we are shifting the displacement. So we have the possibility to control if it is a centered displacement or if it's not centered. We have many value and many parameters there, so we have the possibility to decide how it looks. But you know, in the output, if we go to choose the V-Ray, we have inside the renderer in the option, you see that we have displacement, so it's set to on, and there we have the value. So this is an override, so actually it is behaving how, for example, how much displacement is done. So if we like, we can control the displacement also using this parameter, and there we have some information about the length for each edge is created. So depending also on the resolution of the texture, it will be able to create more subdivision or less subdivision. We have a maximum subdivision for each face, and then we have the edge length. So if we say, for example, 2, actually it is going to create 2 pixel faces. By the way, again, if the texture is not so precise, we'll have nothing more than before. So back to the object, and we say to have a little bit less displacement because it's really too much. Let's go for 0, 0, 2, and we have to lose a little bit also the shift. We can also remove because we are trying to have a really low value for the displays. It is still really high, and let's go for something really low, just a little bit to give a nice surface looking result. You see that it's really, really nice and realistic. Okay, save again. Now if we like, we can play with a camera to have the depth of field. How it works. Depth of field is part of the camera and the rendering. So actually we have no depth of field. We have to go in the output, we have the V-Ray, and in the renderer you see that there we have the camera, and here we have the depth of field. Let's say enable. Okay, it is going to have the depth of field all over, and that's because the focus distance is set to 2 meters, so it's really far. So we have to find a better position for this one, and I think that we are not so far from the object. So let's go, for example, at 0, 5. Okay, you see that it is something like near. We have a really huge amount of depth of field, but it is working in a really nice way, and that's due to the aperture. The aperture is really high, so obviously if we go higher, you see that we'll have more and more depth of field. If we go lower, we'll have less depth of field. Depending on the depth of field we have, we are also managing with the scaling of this object. So for example, if we see something like that, we have a really huge out of focus, so it seems that this object is really little. If we like to see in a more realistic way, we can try to have lower depth of field, maybe also less, so just a little bit. It is not so slow to be calculated, you see. Maybe we need more subdivision, but we have to see if we have grain during the rendering, and everything needs to be tweaked using also the render process. By the way, just to be sure that we have a nice result, let's go a little bit higher to 32. Here you have the possibility to control the shape of the bokeh effects. So here you have the sides, so you can decide how much sides and the rotation. By the way, we can talk about it in a coming tutorial, and we have many stuff there to control the camera. We have many options, so you see there are many information about the global illumination. It is working using two algorithms. It is using the brute force for the primary, and it is going to use the light cache for the secondary. Obviously, when it is going to create the rendering, actually it's working in a progressive mode, and other things. Obviously, just to let you know, we have the possibility there. We say that later we like to render with a bucket. So here we have the sampling, and actually it is set to minimum 1 and max subdivision to 24. Let's say that we like to use the single subdivision we set over the material. So we go in the DMC sampler and say use local subdivision. So it is going to use the value we set for each material, and actually this is a multiplier, so it's using the one we wrote. So for example, if we wrote to have 32 sampling for the reflection glossiness over the plastic, it will use 32. If we set the multiplier to 2, it will go to use 64. We have there the anti-alias, that's the filter size. So we have many things that needs to be we have to take care. Here we have the bucket size, actually it's 64 pixel, but we have the possibility to manipulate. In the advanced, you see that we have the dynamic splitting set to on. It means that if we have lower area and we have a lot of cores, it will go to change the scaling of the bucket dynamically to use all cores, more cores than possible, okay? And that's really nice because it's a way to optimize the rendering. Let's remove this one, so we have the entire render. Obviously, we have an entire rendering engine that needs to be manipulated. By the way, if you like to render the image, you have just to say render to disk, or you can save it from there. If you say in this case render to disk, it is going to use the bucket with this configuration. Here, this is the noise threshold, actually set to 0.01. It's not so much. Let's make a test. Let's say that we go to render just this area, and we say that we like to have a really huge grain, but obviously we have to take care about the real render. So let's say render to disk. Okay, you see, okay, we have just a problem. And it's something that it is doing usually. So let's override the camera resolution, and let's say to specify the one we like. It is the same we had before, and then render to disk. Okay, you see we have to, let's do it for a bigger area. Render to disk. It will go to do the light cache at the beginning, and then it does the bucket. You see that it's changing the size of the bucket, but we have a lot of grain. So if you before we go to change something, I like to add more details to the global illumination too. So the subdivision for the brute force, let's go higher. Let's go to render again. was any kind of problem here. By the way, let's try again to render. Okay, nice. We have still a lot of grain, so if you like to remove the grain, we have to say that the threshold is lower. The default is 0.01. Rendering will be a little bit slower than before, obviously, but the quality will be higher. You see that it's going slower, but we'll have a really low amount of noise, and we are not taking care about optimization because we done nothing about the sampling, so it's not optimized. By the way, the quality is really nice. I mean, and this way it's going to save the image in the render folder, obviously. It is everything, it is set there, so you see that it's rendering, it is saving there with the right file naming. If you have the AOV, it will save it, but we have to take care about the settings. And other things, if you like to render a complete animation, let's do something. Let's remove this one and let's go to render. You have just to change the valid frame range from current frame to the right animation set and write the frames you like to export. Here you have the possibility to change the camera for the final render, and that's all. Obviously it is really more complex than what you see, but it is just a really simple introduction. So you see how to play a little bit with the displacement, how to create some material using texture for the material control, adding the depth of field, and play with a render to disk, render, progressive rendering to play with the scene, etc., etc. Okay, guys, it's done. It was a render for 5 minutes. It needs obviously optimization to be really faster. And remember that everything it was done there can be done also using the GPU. What I mean, if we go, for example, to this area and we change from CPU to RTX, let's see if we have it. We can say here to use the CPU and to use the GPU and apply. Then when we go to render, it will take care about using the GPU renderer. Okay, so actually V-Ray GPU is really amazing. It has a lot of options, really similar to the other version, and you see it needs a little bit of love and time to move data from the CPU to the GPU, but then the rendering is really fast. So if you'd like to use it, you can make some experiments. By the way, we'll go to use it in our coming tutorials, so don't worry about it. We'll talk about the GPU version really soon.